Let's see.
Winner?
The bear. Okay, bear. Cool.
No, I said the winner thing. Trophy?
Trophy. Okay, the trophy. Okay, good. Who else? Who else? Don't be shy. Yvonne? Okay, thank you.
My name is Yvonne Lee, and I am from California, and I am 7 years old, and my birthday is September 17th.
Oh, wow, same as Jolene. September 17th.
I already knew
Woo!
Uh-huh.
You send happy birthday next week for you. Okay, which sticker would you like?
Bear one. The bear.
Bear.
The bear. Okay, good. Good. Bear. Okay. Mason or Amber. Mason. Whoever wants to go first. No? Try to pick a sticker. You got to you got to get 2 stickers. Whoever pick a sticker next is going to get 2 stickers. So go ahead. Who wants to introduce yourself? Okay, Amber.
My name is Amber and I am 8 years old. I live in Fremont, and Locke Avenue.
How old are you again?
8.
8. Okay, which sticker would you like to pick? Which one?
Any sticker.
Any sticker. Okay. 8 years old, Amber. Is your brother going to attend as well?
Yes.
Would he want to pick a sticker too? Ask him.
Aiden Chi, did you see him?
Yes, I am Amber Chi's brother, and I'm 6 years old.
6 years old?
Yes.
Okay. Aiden, right? Aiden. Okay.
Yes.
I don't see your face. I only see the mom's beautiful hands. Okay. Okay. Aiden, 7. And which sticker would you like to pick?
The chicken.
Chicken.
Chicken the last.
Which one is the chicken? The bird?
Yes. Yes, the bird.
Oh, the bird. Okay. The bird or the horse? Or
Bird.
Okay, bird. Okay, cool. Okay, Mason. Oh, I saw you were only attend on Wednesday. I'm so glad you could also make it on Thursday. Mason, introduce yourself. Mason is from Hawaii. Oh, S to unmute. Mason, are you there? Are you Carson or Mason?
Mason.
Okay, pick a sticker for you. The bear? The dinosaur?
The game controller.
The game controller. Okay, introduce yourself. How old are you?
I'm Mason. I'm 7 years old and I'm from Hawaii.
It's only 3 o'clock in Hawaii, right? Yeah.
That's 308.
3:08. Okay. So welcome again. I'm so glad. Oh, Amber got 2 stickers, right? Because I thought whoever picked the next one got 2 stickers. You know, those are just random surprise. Encourage you guys to speak it out loud in class. Okay, so first of all, let's go. If yeah, most of you already joined this class. If you haven't joined, please you can copy this. I mean, you can join here. I'm going to copy this to the Zoom chat. So so if you haven't joined, you can do. I think most of you already joined. Okay, and the first slide link is posted here. So let's just begin with the introduction. I have a little videos that I'm going to show you.
On a computer, you can do all sorts of things. play games, do your homework, watch videos. All of these things are done using computer programs. A computer program is a set of instructions that a computer follows to complete a task. You can see computer programs in action all around you. They control things like cell phones, coffee makers, cars, microwaves, washing machines, gaming consoles. If we didn't have computer programs, these things that we use every day would not be the same. Most of them wouldn't even exist. So computer programs are important and help control a lot of the devices and machines that we use every day. But what are these programs made from? Computer programs are made out of their own special computer language called code. A computer can't think for itself. And you can't talk to it like a person. This is because computers don't understand the same language that you speak. Computers only understand code. If we want a computer to do something, like make a game, you can't just tell it to. You need to give the computer step-by-step instructions for how to make the game in a language it understands, code. Computers need code to do pretty much anything. Computer code is usually made out of words and numbers like this. Programmers like you are people who learn how to put these words and numbers in order so your computer can follow your instructions and know what to do. In Smeeborg, your fuzz character acts just like a computer. Your fuzz can't think for itself and needs a programmer like you to tell it what to do.
Okay, I'll stop here because in this video, it introduces you the concept of coding or a computer, because we can see all those computers almost everywhere, right? In the microwave, inside a car, of course, inside a game control. And oh, I just noticed Abby and Ashley just logged in. Hi, Abby, would you like to introduce yourself? How old are you? And pick a sticker for yourself.
I'm 7 years old and my name is Abby.
Okay, can I give you a bird? We are going to collect stickers throughout this course, and at the winner at the end of this course will win a special prize. Okay, I saw Aiden earlier, but he disappeared. Okay, we're missing one more. I'm sorry, not Aiden. Brian. Yeah, I saw Brian earlier, but he's gone right now. Yeah, that's fine. Okay, yeah, so let's just begin with like a simple coding. Okay, I'm going to run this together with you guys. So let's do this puzzle together. Okay, so when we try to create something for computer to walk around, you have to tell computer what to do. Okay, and in order for the computer know what to do, you have to tell him the instructions. Okay, and before the computer can understand the instruction, they need to understand some kind of the data. So we have to try to create some kind of patterns that you can store the data. So in this puzzle, we have to identify certain pattern. Okay, just try to put the things into the right area so we know which pattern is the same. Okay, so you know, like a picture, we definitely to look for the picture of the bees or the duck or the snail or the cat. Okay, who would like to try? You can snap anything together, but you have to make it logical. Okay, so Amber, would you like to try first? Okay, I saw you raise your hand. Yeah. So tell me which one you want to plug in. So you can either choose a picture or choose a trace for a specific animals. Say feather belongs to where, or I think let's begin with the picture. That would be most easier. Okay, Amber.
Put the picture of the bee with the stinger to the word that says bee.
Okay, good. You want to try another one? One puzzle, one sticker. No? Okay.
Okay.
Okay, yeah, then keep going.
Put the word stinger on the bee.
Stinger on the bee, right? Wait. Stinger, right?
Yeah.
Okay, I accidentally grabbed the shell as well. Okay, good. Okay. Abby, you want to do the next one? Rosalind, you will be the next. Okay.
Put the cat on the cat thing. The cat.
Cat. Just for Amber, 2 stickers. Cat to the picture, right? Here. Okay. What else?
Put the dog to the dog.
The dot. Here or here? Here? Up or
Here.
down? Here. Up.
Up.
Okay, good. And okay, thank you, Abby. And Rosalind, you want to be the next one?
Snail put to the snail.
Snail put to the snail. Okay, good.
And put the shell in there.
Good idea. Good idea.
And the slime.
Shells and slime. Oh. So
And on the bee put the honey.
on the bee put the honey. Oh, you know a lot. Oh, you got 3 stickers already. And that was Rosalind. Who else?
And put the feathers on the duck.
Which one? Feather on the ducks. Okay. Wow, 4 sticker.
And put the
Oh, okay. Save it for other
Yeah.
people. Save it for other people. I know you're going to win again. Okay. Aiden, would you like to try? Yvonne, you will be next. Okay. Aiden, you can just unmute yourself.
Put the whiskers into the cat.
Whisper into the cat. Okay.
And the fur into the cat again.
Okay.
And the beak to the dog.
Okay, we save it. Save the last one. Okay. Okay, that's fine. Yeah. I'm going to give it a sticker for Aiden. That's 4. Okay. Don't worry, Yvonne. You're going to be the first one who try to solve the next puzzle. Times 4. Wow, that's a lot. Okay, so in here we actually trying to create a structure of the data holder that we're going to hold the information that the computer is going to store. So in here we define the name of each objects. That's a technical term. It's called objects, and like the name of this object is called the B. And inside there we actually store a picture. Okay, so this animal, every animal has their own picture. Oh, we haven't finished this legs. Okay, Yvonne, would you like to try this? Which one would you like to try? The legs. We got to assign a leg for each of the animal. You're muted. Can you unmute yourself? Would you like to try? Cat. Do you think how many how many legs does a cat have?
4.
4. Okay, good. Would you like to try another one?
Yes.
Snail?
Mm,
The snail has 0. Okay. Okay, good. How about a bee?
4. Wait, 6.
6. Okay. Yes. Okay. And yeah, let's put 6. Okay, let's save the last one for Mason. Mason, would you like to try this? You can unmute yourself.
Not muted.
Oh, okay. How many legs does the dog have?
2.
2. Okay, good. Check the answer. Good job. Okay, so in here, we actually create a data collection of different animal. But in this animal, we're trying to collect different data, like the leg and the trace and the picture over there. Okay. So that's how the computer is store the data. We got to give a placeholder to store it, and that's called coding. Okay, like coding in a variable, we got to have a data first. Okay, but and the next things we're going to do is to give them the instruction. Like for example, here, this yellow man is going to go to this goal or this destination, and you got to give it the computer instruction about like how to go to the goal. Okay. Who hasn't tried it yet? Aurora, would you like to try this?
Yeah. Sure. So I think you just do move forward.
Okay. There we go. That's very easy, right? Good job. Who wants to try this one? Rosalind.
Move forward and turn left.
Turn left.
And then forward and then turn right.
Turn right. Okay, let's try it.
I said then move forward.
Oh, okay. Sorry, I missed it. Where? Move forward, turn left, turn right, and what? Oh, okay. I missed the last move forward, right?
Yeah.
There we go. So you see, whenever we are trying to give the block, I was dragging this block to here. It actually generate the code for me here. Like move forward. This is one function. Function is like you ask the computer to do something, and this something in this case is move forward. Okay, and turn left, move forward, turn right, move forward. Okay. Easy, right? Very easy. Okay. This one we are going to use something called a loop. Okay. The purpose of having the loop is that you don't have to do the move forward for many times. You can just ask it to repeat it until you ask it to stop. Super easy for you guys, right? Yvonne.
Grab the repeat until do around the forward, move forward.
Okay, is that all?
Yeah.
Wow, super easy. Okay, you see the code for this while not done. So not done is another function. Sometimes they put while true. That means that you will always do it. But in here, the not done is like I'm not going to. I haven't reached the destination yet. Then it will just continue repeat by yourself. That's how computer is very good at just trying to do something repeatedly, and then you can just give one instruction and it will just go doing running. That was Yvonne. Okay. Who is Sammy? Who is Sammy?
Me.
Rosalind? Okay, Rosalind. Okay, go ahead.
Do and
Okay.
then move forward thing, and then do turn left,
Okay.
and then forward, and then turn right.
Turn right. Do you need
No,
another?
I said move forward, then turn right.
Move forward. Wait, he's heading this direction, heading east right now. Okay, so you move forward and turn left or turn right?
Turn left, and then put the right away, and then forward, and then put the turn right.
Ah, okay, got it. Is that all?
Yeah.
Okay, let's see what happens. Yay. You see that it will highlight the steps it's currently executing. Okay. So again, we have another while loop. While not done, it will move forward, turn left, turn right. So this will save us a lot of codes. We don't have to like move forward, turn left, move forward, turn right for 4 times, right? So we have actually 1, 2, 3, 4. Yeah. So it will save us. If without the loop, while loop, we actually have to write like 4 times 4, 16 lines of code. But with the while loop here, then we can easily shorten our code into like just 6 lines here. Okay. Good job, Rosalind. Who wants to be the next? Super easy for you guys, right? Who hasn't been called? Aurora, would you like to try?
Okay, but I might be wrong.
No, I believe in you.
So I think you just do 2 move forward,
Move forward, okay.
and then do repeat until,
Okay.
and you do, wait, I think I forgot, you have to turn the direction, like
Yes.
turn left, I think.
Okay. It's after the move forward, right?
And then you just do move forward.
Okay. Good. Good job. See, I know you know how to solve it. You can do it. Yeah. So 1, 2, 3, 4, 5, 6. We have 6 lines of code written here. But again, we use the while loop to save us like 1, 2, 3, many steps. I don't even want to count it. Okay. It's getting more and more challenging. But what time is it? We already halfway, but let's save it for later. Right now, you get an idea right now because we are giving the computer instruction. Right now, I want to go back to my slide. If we have time, I'm coming back to here. Oh, my slide here. Okay. So yeah, you get the idea. So there are 2 parts of coding. One part is about data. Okay, you got to have some placeholder. You can store the information about your data, like a these. And the other part is the instruction. You got to tell the computer where to go. So the computer is a combination of data and the instruction. You got to have a placeholder to store the data, and then make it to do something. Okay. So now let's do some coding. Okay, so in here it's too small here. This is very similar to the phonics things you guys did before. Yeah, probably in kindergarten. So here I have the instruction. I will give you a certain number, and in order to find out what character you need to fill into the blank, you have to follow certain instructions. Say like the number here 2, 3 means you have to go the second row here and the third column here in order to get this number H. So that's one instruction. Okay, you have to find out the instruction for how to identify this. Sorry, can you close the door? So that's one instruction. And then once you identify the instruction, then you stored the data, the H, you stored it here. Okay, and so for 11, I mean, yeah, 11 is like here, first row and first column. Then we got the A here. Okay, so 5, 2 is here. Fifth row is fifth row is here, and the second column we got the V here. Okay, so let's try to you probably got the idea, right? Anybody want to explain more about the rule? Abby? Abby, you want to work on this puzzle, or you have question?
Work on this puzzle.
Okay, go for it. 33, what's the number for that?
M.
M, good job. Do I have a annotate? Okay. Annotate. So this will be an M. Okay, good job. And who wants to try the next?
Me. Me.
Yeah, I know, Russell. Maybe let's give Aiden a try. Hi, Stanley. Aiden, would you like to just unmute yourself? Where's Aiden?
E. I said E.
E. Okay, E. Okay. Did I give Abby a sticker yet? Can you help me with Abby a sticker? And who said the E? Sorry, Aiden, right? Aiden and Abby. Yeah, give Aiden one sticker, Abby one sticker. Okay, and yeah, so good job. You guys get the idea. 11 again. Who wants to try this one? Amber.
11 is A.
A, good job. Oh, give Amber a sticker. Thank you. How about the last one? Stanley.
32 is L.
L.
That's good.
Yeah. Stanley just logging. Would you like to introduce yourself? And Brian?
I am Stanley and I am 8 years old.
Really? You just 8? I saw you already 10. You can work on challenging puzzle. Okay. Okay, I assign you a random sticker, global. Okay. Yeah. So we solved this puzzle. It's a male, right? You see, this is like we need a placeholder. Sorry, I'm going to new one of you. Let me. Okay. Thank you. Yeah. So in this example, we actually use two type of things. That one is the instruction. The other is the data. We follow the instruction in order to look up the code. And then once we got the code, and then we stored it in this placeholder. Okay, so this is one kind of encoding on computer coding. Okay, how do I clear this? So in here, this is the ASCII code. Annotation, clear everything. Okay, so here is a list of the table of ASCII code. This is the actual coding computer is using right now. but we have so many different kind of encoding name, and ASCII is just one of them. Can anybody tell me what's the number for a heart, a black heart? What's the number for a black heart? Amber.
3.
Yeah, 3. You're very good. Amber, where are you? Can you just? Oh, here. Okay. Okay. How about for the letter capital A? Capital A. Capital A. Who is raising hand? Who hasn't speak yet? Yvonne? Capital
65.
A. 65. Good. It's here. 65. Good. Where's Yvonne? Yeah. Good job. You guys are so good. Where's my next slide? Oops. Okay, so now let's play again. Another game. So in this game, I'm going to give you a rule. Here. I'm going to give you a rule. I'm going to give you a number. Okay, so in this number, say for example, I have number 3. Number 3. And you have to follow the certain rule. That's the instruction, okay? And the rule is, if this number is greater than 0, then we're going to repeat it. We're going to repeat for this part. So if this number is greater than the question mark, like right now I have 3. If it's greater than number 8, then I'm going to turn this light bulb off. Oh, and then I'm going to move forward to the right side. And if it's greater than, I turn it off. Else, if it's smaller than, and I turn it on. Okay, so I know it may be a little bit challenging. Let's work on number 3 together. Okay, is 3 less than 8? Is 3 less than 8? Yes, right? So 3 is greater than 3 is greater than 8. No, right? No, right?
Yes.
3 is greater than 8. Yes?
No.
No, right? No, right? So
Yeah.
so it's off. I think I wrote it's greater than, oh yeah, it's greater than, okay. So it's no. 3 greater than 8. No, so this one is off. Okay, and then let's move to the right side. Okay, is 3 greater than 4?
No.
No, okay, so let's turn it off. So it's still off. Okay, is 3 greater than 2? Yes. Okay, yes, let's turn it down. Okay, I'm going to duplicate it. Let's turn it down. Okay, it's 3. Okay, also once I turn it on, I have to use 3 to minus 2. Okay, so that's a rule here. 3, the question mark is 3, 3 minus 2. So I have 1 left, right? And I keep moving forward to the right side. So right now I only have 1 left because the question mark right now, minus 2 equals 1. So right now the question mark becomes 1 right now. Okay, but let's continue to repeat this. Okay, to the right side. And we finish this side, and is 1 greater than 1? Okay.
No, it's exactly the same.
It's exactly the same, right? So this rule doesn't work on. This rule is not valid, so we have to turn it on because we have to follow the second rule here, second instruction here. So we turn it on. Ooh. I need to duplicate it. We turn it on. Okay, so in this way, the number 3 is actually, we got 2 light bulbs, and eventually we put these 2 numbers together. Is 2 plus 1, that's equal to 3. Okay, So that's how we represent number 3 into like 2 light bulbs. 2 light bulbs at the end. If we have 4 light bulbs, we turn the first 2 off and we turn the last 2 on. Did you guys get the rules of this game?
Yeah.
Okay.
Yeah.
Okay. Let's try another one. Okay. Who wants to take this challenge? Let me try 5. 5. Okay, Amber, you want to try? No?
I want to try.
Okay, Rosalind. Amber, you want to try first? Okay, yeah. Okay, she raised her hand first, so give her a chance. Number 5. Okay, let's begin with from the left side. Is number 5 greater than 8?
Number 5 is less than 8.
Okay, so let's turn it off. Okay, and move to the right side. Okay, now is number, okay, let me, because I got to reset this. Everything is off right now. Is number 5 greater than 4?
Number 5 is greater than 4.
Yeah, so it's off, right? Because it's number 5, question mark is number 5, right? And the number is this 4. It's greater than 4, so it's off, right? Yeah. Okay, let's move to the right. Is number 5 greater than 2?
Number 5 is greater than 2.
Yes, right. Okay, so let's turn it on. Eh, did I write it wrong? 5 greater than 5. 5 greater than 2, and it's turn it off. Else turn it on. 5 greater than 2. Oh, okay. Oh, sorry. Here, 4 is like 5. 5 is greater than 4, right? So I have to turn it on.
Yeah.
Yeah. So here, sorry. So this one I need to turn it on. Okay. And then because I turned it on, then the 5 needs to be, once I turn it on,
it becomes 5 minus 4.
yeah, 5 minus 4,
which is 1.
which is 1. That's right. Sorry, I think I wrote it wrong. Greater than this number, I need to turn it on. Otherwise, it's turn it off. Yeah,
Is it my turn yet?
otherwise turn it off. Yeah. Okay, so it's number 1 right now. So 1 is 1 equal is greater than 2?
Number 1 is less than 2.
Yeah, so we leave it off. We only turn it on if it's greater, right? So right now only have 1. Okay, so this 2 we have it off, and move forward to the right. It's number 1. I think this one it should be greater or equal. Yeah, sorry, I rewrite the rule. Okay, and so 1 is greater or equal than 1, right? So we leave it on. So let's duplicate it and leave it on. Okay, so to represent number 5, we can use 2 light bulbs, like 4 plus 1, which is number 5 here. So that's how we use, we try to encode it into 4 light bulbs. So this concept is called bits. Like 1 light bulb is called 1 bit, and each light bulb has its meaning. Like 1, 2, 4, 8. It has a special meaning. So we actually decompose it. The number 5. Let me try to write it. Oh, I feel I'm teaching math right now. 5 equals 4 plus 1. But we're trying to represent the number into 4 bits. So it will be 0, 1, 0, 1. Whenever the light bulb is on, then we put a 1 here. Whenever the light bulb is off, then we put a 0. So That's how we convert the decimal number, which is number 5, into a binary number, into a computer number. I know it's a little bit challenging, but just think the way this is like how computer is working. You got to give an instruction and you got to have a data. So this way, the computer is stored number 5 into 0101 here. Okay, Aiden, you have question or you have?
How do you do the next thing?
Okay. What can we have? 6. Okay, we can do one more. Yeah. Let's try number 7. Let's try number 7. So let me reset everything. Okay, is 7 greater than 8?
No.
No, right? So let's leave it off. We only turn it on if it's greater or equal. Okay, is 7 greater than 4?
Yes.
Okay, good. So we turn it on because it's greater than that. But we got to minus that. 7 minus 4 equal 3, right? So
Yes.
this question mark right now changed to 3. Okay, is 3 greater than 2?
Yes.
Yes. So we do what? We turn it on. Okay, because it's greater than the 3. Number 3 is greater than 2. We turn it on. Okay.
Yes.
And right now, so we minus because whenever we turn it on, we got to follow the rule. We turn it on. Oh, sorry, the rule. Oh, yeah, I think I just rewrite the whole thing into the opposite. So whenever we turn it on, we got to minus the number. So 3 minus 2 equal 1.
Yes.
So right now the question mark becomes 1 right now. Okay.
Yes.
And then we move to the right side. Is it 1 greater or equal to 1?
Equal.
Yes, right. So we turn it on again, right?
Yes.
Okay. Woo. Okay. So there we go. And we minus 1 equals to 1. I mean 1 minus 1 equals to 0, right? So once it's 0, then we finish, right? Because the loop is no longer valid. 0 is not greater than 0, so we don't have to do anything. We're done. Okay. So this number 7. Okay. Another math gain. I mean another math calculation. So 7 equals 4 plus 2 plus 1. Okay, and in binary representation, it's called 0, 1, 1, 1. Whenever we see the label is 1 here, then we put a 1. I mean, label is on, then we put a 1. So 0, that's the first one, is off. The second one is on. The third one is on. The last one is on. Okay. So this is
那我了吗？
我们还有下一个好不好？这个观念差不多了。You guys get the idea, right?
Yes.
Yeah. Okay. Now you guys can code this number. You guys can code number 7 into 0111. 0111. Yeah, 3 1s. Sorry, did I give a sticker? Who was that? Amber was doing that earlier, right?
Yes.
Here. Did I miss anybody the sticker?
Me. I was doing that in the final.
Oh, okay. Aiden. Yeah.
The rainbow.
The rainbow. Sorry, I'm just giving random one. I don't want to say. Yeah.
The other sticker.
Huh?
The other sticker is below.
Can I give you a penguin right now?
No. Well, I know. No, there is a rainbow in your sticker.
Yeah.
If you just can show it, then I can and say that.
I'm sorry. What, did I miss you a sticker? Okay. Okay, yeah. So let's go back to my slide. Okay, what else do I have? So that's actually the concept of bits. Like we put everything into 0, 1, 0, 1. And right now let's do, we have 10 minutes. Let's try to create a program. It's called password generator, right? You know, whenever you try to type into computer, you don't want other people to know what you guys typing. That's why in here, like I'm trying to give you a certain number, but actually it means something. But whenever we want to create a password, sometimes we forgot it, right? But you want to have a key phrase that you remember. Say, for example, here you remember it's meal, right? It's a meal, but you actually type in 33 15 11 32. So that's your password, okay? But right now, let's do some exercise about a password generator. Where is it? Oh, here. Okay. So for example, right now I have A to Z, but whenever I type A, I don't want to actually type A. I actually type D. A, B, C, D. I actually type D. So everything I shift by 3 characters. Whenever I type A, I actually type D. Whenever I type B, I actually type E. Whenever I type C, I actually type F. Okay, so so that way I don't have to remember my password. I just know how I create this the rules for me to create this password. For example, can you give me a number like God? Okay, sorry. Let me take an example of God. God. So whenever I want to type G, instead of typing G, I type is it K or a J? K. Number 1, 2, 3, 4, 5, 6. J. Yeah. Instead of typing G, I actually type J because it's three later afterward. Okay, you can actually 1, 2, 3. Yeah, G. So let's do one exercise. Let me have a G. G-O-D. God. And I actually type into J. Who wants to try this one? O, instead of typing O, I counted 3 letters afterward. Stanley.
So it will be J and then an R and then G.
R.
Yeah, J or G.
Oh, J or G. Yeah, because I'm actually jumping 3 letters afterward, right? So that this way I create with my own password, but I still remember it. I just to know the rule, the instruction for that. Okay. And another thing is like you don't have to jump like 3 letters afterward. You can specify your own distance. Like here.
What?
Yeah, you can create your own rule. That's why.
No. I mean, like my computer just opened an app.
Oh, okay.
I don't know why.
Okay. So we create the password in different rules. So in this rule, maybe I say, oh, D will equals to, I mean, whenever I see D, I want to write it I instead.
Yeah.
Whenever I see K, I want to write O instead. Whenever I see R, I want to write B instead. Okay. It's a bit challenging now. Are you still following me with me? Give me a sum up if you still follow me, right? Okay, Aurora, good. Amber, thank you. Rosalind, did you get what we are doing right now?
Yes.
Okay, so now let's create your own rule. Does anyone want to try how you create your rule? You can just draw anything. You can jump in any distance. Let me know, and I'm going to write it. Curry. Who wants to try this one? Let's give somebody who hasn't tried. Yvonne, would you like to try? So maybe for the letter G, instead of G, which one would you like?
P.
P. Okay, good. So let me give it an error. Where is it? Did I see it? Oh, okay. So it has an arrow. Instead of G, then we are using P right now. Okay. So that's one rule. Very good. Very good. And who else? Brian, would you like to try? Would you like to try? Maybe for the letter J, instead of writing a letter J, and which one would you like to change it to? Which password would you like to change to? Just give me a letter. Brian, give me a letter.
J.
J, yeah. Which letter would you like to change J to? You can change that to a different letter so you have a password.
V.
V, okay. Ooh, that's a long jump. V. Okay, let me set it here. Okay, oh, it's a little bit hard to read. Okay, yeah, so now we have a password generator machine. Let's try to use this to generate a password. Say right now, I want to say is. Okay, so from this password generator, what do I put here? Oh, I didn't encode I and S. Okay, let's change a different word. Maybe DOG. Okay, DOG, because we encode D. So what do I put here? Instead of writing D, what should I put? Who wants to try this one? Stanley?
So it's gonna
D,
be
instead of writing D, you write
J.
Yeah,
Uh,
that's the I, right? That's the I.
yeah, I.
And
then
O,
O.
O is still O, right? We didn't change it.
Yeah.
And
And
how
then
about G?
G is going to be R. And also there's one thing I want.
G goes to P, right?
Yeah.
G here.
Yeah.
Let me change the line. Probably the line number is, yeah, goes to P. So DOG, we instead of typing DOG, we type IOP.
Yeah.
So that's our password.
Uh-huh.
Is it too? Are you guys get it?
There's also something I want to say. Oh, so it's two things actually. One, I've made a program that's like this, but you can also change the number that you shift.
Can talk the day. To win an eye funny.
Yeah, so there are two ways to create this coding. I mean, actually, you can create your own way.
Yeah, and
That's
two,
why
if you ever have to shift any like Z or Y or X or W, then it actually just restarts.
yeah. So this one, if I shift it, if I shift it, and the remaining part will be going to here. So it actually, I should put it in the front. In the front, and I shift it. Okay, So that's my new code, right? My lookup code for this one. Okay. I hope this one is not too challenging for you, but yeah, I think most of you did it very well. Okay. We have 1 minute left. Any question before we talk about homework? You understand? Yeah, did you guys understand this? Okay.
Yep.
Good. Thank you, Aurora and Amber. Thank you. Yeah, so for homework, I think you can try to solve the puzzle. Where's the instruction? Oh, we finished this in class. Okay, so for homework, let's just try to create a password. Okay, where's my? Let's just try to create a password. Okay.
Too hard.
Huh? It's too hard?
Too hard.
Okay. Let's just do this puzzle then. Yeah, finish this puzzle. Finish this puzzle as your homework. Okay? We finish this. I'm going to put this. Yeah, I think that's the right link already. Not this one. Okay. Just update it. So you can finish this puzzle as a homework, and then we can come back with the password later. Okay, so now you have the writing. All right, any questions before? Yeah, so don't worry too much if you think the password generator or these things is too hard for you. We are going to revisit next time. Yeah, this one, I just want to give you an example. This is how the computer actually works. But if you can solve this puzzle, you can give computer certain instruction, you are good for today, because that's the main purpose, like giving instruction. Amber, you have question, comment?
How do I type in the code?
How do you type in the code? You mean this puzzle or what?
I mean, how do I type in you play encode unit 1? Oh, you try stay on touch ID.
How do you type? I'm sorry, I didn't quite get your question. 你要在这边打还是什么？
I mean, how do I type how do I type? I don't have any things that says type.
In
anything,
the PowerPoint? In the PowerPoint or where?
And I mean the homework. I can't type.
Oh, okay. So here you just upload a screenshot. You don't have to type. Once you finish the puzzle, and then just take a screenshot, and then when you turn it, you can attach a screenshot there. Is that okay? Yes. Okay. All right. Yeah. It's time for Dina. Thank you so much for your patience, and yeah, just work down the puzzle as soon as you can finish this puzzle. You guys are awesome. Mason, you have a question? Yeah, if you guys have no question, you feel free to leave. Yeah. Okay. Bye. Bye. And if you have questions, stay here. Bye. Stay here if you have questions.
Hello.
Hello, Rosalind. 你只要会做这个 puzzle maze 就很厉害了，好不好？我今天
很简单啊。
很简单啊，太简单了。那你要不要做那个灯泡那个？
我想要弄这个。
好啊，那你做这个，做完。
我已经做完到10个。
好啊，那你把 upload。
我已经 upload
了。No，Joshua， 你昨天的不是这个，是另外一个，你的是那个小鸭鸭的。
对，我的单题我已经 submit 了。
哦，好棒哦。
那个我弄到10。
然后 Rosalind 是做这个妹子迷宫的。 Brian, you have any questions? I know you come in late, so hopefully you get what I'm saying.